Hello, this is Agbamu Itanogrene, here to teach mathematics on the topic coordinate geometry. And these are my objectives in today's class. Identify the intercept of a straight line. Determine the equation of a straight line using gradient and intercept. Determine the equation of a straight line using gradient and 1 point. Then determine the equation of a straight line using 2 points. Alright, let's see what we have to do today. If you recall our last class, we treated gradient, and we said gradient is increase in y divided by increase in x. What we mean by that is we are looking at the changes that takes place in y. How does y changes from y1 to y2, then divided by x1 to x2. That is why we said gradient is equals to y2 minus y1 divided by x2 minus x1. So take note of that. So that was what we did last. But today we want to see how we can use the same gradient to get equation of a line. This is another important aspect in this topic. Equation of a line. Every line has an equation, and you should be able to determine it if you are asked to do it, especially in this topic, coordinate geometry. But before we go straight to equation of a circle, I want us to understand what intercept means. Since we know what gradient means now, so we should be able to know what intercept means. Let's see this sketch we have here. You can see this straight line A to B. You can see it on this graph. So A to B is a straight line, and point A, you can see the coordinate of point A, which is 6. For x is 6, then y is 6. Then coordinate of B, the second point here, is minus 9x. Then the coordinate for y is minus 4. You can see it clearly. Okay, now how do you know intercept in a graph? When you plot a graph, there's always a point where the line crosses the y-axis and the x-axis. For example, in this sketch we have here, this graph we have here, you can see that the y-axis, the graph crosses it on this point 2 here. So this point 2 is called an intercept. This is y-intercept. Then on the x-axis, you can see that the graph also crosses the x-axis on this point minus 3. So this point minus 3 is also an intercept. But in equation of a line, the intercept we need is the y-axis intercept. So that is what we need. And another important thing about intercept is this. At the point where the graph or where the line crosses the y-axis, you can see that x on this point is 0. So let me show the y-intercept so that you see what I'm saying. You can see the intercept for y is called point C, and you can see that x is 0 while y is 2. So x is 0 at y-intercept. So these are some concepts you need to know, because there are some questions whereby they will give you equation of a line. They will give you an equation and they will tell you to find the value of y-intercept, or they can tell you to find the y-intercept. All they just wanted to do is to make x 0 in the equation, then you solve for y. I will still treat an example of such so that you get what we are talking about. At least I will use this example at the end to do that. Then the same thing with x-axis. You will discover that when x is minus 3, y is 0. So in your x-intercept, y is 0. If I put show x-intercept there, you will see it. You can see the x-intercept. Y is 0, x is minus 3. So these are two important information you should know in equation of a line. Y-intercept and x-intercept. At y-intercept, x is 0. So you can solve for the value of y when x is 0 if you know the equation. Then you can solve for the value of x when y is 0 if you know the equation of the line. But now I think you know what intercept means. The point where the line of your graph crosses the y-axis and the x-axis, those are the intercept. But for equation of a line, it is this one we need, the y-axis. Alright, now let's see what we have now. So this is a straight line now, and the y-intercept is c, which is 0 for x, y for 2. Now let's see, how can we get equation of a line using this format now? Let's start with the first one. From our objective, we said we should determine the equation of a straight line using gradient and intercept. So let's start our statement so that you get what we are talking about. So if I want to find equation of a line, whereby gradient is given and intercept is given, how do we do that? So equation of a line using, let's start with this, using gradient and y-intercepts. So let's start with this. So equation of a line using gradient and y-intercept. So for us to do this, let me underline this one. Okay. So for us to do this, let's give the variables the name, the variables we are going to use. For example, we need m as a variable. So let's put it in statement. Let m equals to gradient. Let x equals to m equals to gradient. So I want us to use m to represent gradient in the equation we are going to derive. Then another important thing we need to derive is c, point c. So let's call point c, let's call it the y-intercept. So point c is the y-intercept. Okay, so these are the two variables I need, c and m. So take note of that. Okay, so if c is the y-intercept and m is the gradient, let's see how we can prove it now. Okay, you remember your formula for gradient? We said gradient is, let's put the formula now. So if m is gradient, so gradient is equals to, we use y2 minus y1. This was the equation we used to derive our gradient. Then divided by x2 minus x1 minus x1. So this was the equation we derived for our gradient. And what does this y2, y1, x2, x1, what does it mean? It means that the second coordinate is y2, then the first coordinate is y1. Then the first coordinate is x1, while the second coordinate is x2. So what I mean by that is the line you need the equation of the line you want to get the equation of the line, pick any 2 points on that line. Let's go to the graph so that you understand what we are saying. So let's pick any 2 points, but since our focus in this example is intercept and gradient, let me pick a point. Let's just take a point here. Okay, so I pick a point on this line, this point. Let me just give these points coordinate of x and y. Let's just say the coordinate of this point is x and y. So this is the coordinate of this point, x and y. Okay, why I labeled this as x1, as x and y, so that we can use it to derive the equation of the line. You know, this I'm trying to derive the formula to calculate the equation of a line when the intercept is given and a point is given. That's what I'm trying to do. So I don't need to put the actual value of this point, which is 3 and 4. That's why I'm using x and y. Then the second coordinate I have here, which is the intercept, this place you can see that x is already 0. On the y-intercept, x must be 0, then y we have a value. So let me call this point 2, this coordinate of 2, let me call it c. So if I call this point c, so This is what we are talking about. Okay, so if instead of 2, let me call this coordinate C. So now let's derive the equation of the line, the formula to calculate the equation of a line when a point is given. So our gradient, we said gradient is y2 minus y1. So this is the first point. Point C is the first point, and the coordinate of point C is 0 and C. I don't want to use numbers since I'm trying to derive an equation. The coordinate of point C is 0 for x and C for y. So this is point 1. Then this is the second point. So this is y2, this is yx2. y2 and x2. So let's substitute this into the gradient formula. We are going to get this. Take notes. Let's substitute it. If I substitute that into this gradient formula, I'm going to have m is equal to, now my y2, let's go to the graph. My y2 is y and my y1 is c. I'm not using 2, I'm using the value, the c, the variable c, so that we can derive the equation. So y minus c is my substitution here. So y2 is y minus, so y1 is c, then divided by x2. Let's go to the graph. X2, we use x as x2. No, these are the 2 points I'm focusing on to derive my equation. Take note of that. So x2 is x, then x1 is 0. Then this is x minus 0. Alright, so now let's solve and get our equation now. So if I keep solving now, I'm going to have m is equal to, so we have y minus c divided by 0. X minus 0 is x. No, 0 means nothing. So x minus 0 will give us x. Then when you cross multiply now, when you cross multiply, x will multiply m. You are now going to have y minus c is equals to mx. You know how to cross multiply. X will multiply m. This is just a basic algebra equation, algebra steps. Okay, then if I take my c, no, this is minus c. Minus c come to the other side of the equation. Collection of making y the subject of this equation, which is y, will now be equals to mx plus c. So this is the equation. So this is the equation of a straight line. Y is equals to mx plus c. So when gradient is given, the y-intercept is given, you can use this formula to calculate the equation of a line. So take note of this, is very, very important. That is what I mean by equation of a line using gradient and y-intercept. And that is our second objective here. Determine the equation of a straight line using gradient and intercept. And the intercept we need is the y-intercept. And this formula is very important in mathematics, especially when it comes to a straight line. M is the gradient, take note of the meaning, then C is the y-intercept. Okay, let's go to the next objective that says equation of a straight line using gradient and 1 point. Okay, let's see how we can do that. Equation of a line. So let's say equation of a straight line. Take note, they are straight line. Equation of a straight line using gradient and a point. Okay. So in this particular type, the value for the gradient will be given. That's one thing you should take note about this particular type. The first one we did, the value for the gradient is not given. We just use the equation of gradient to get it. So take note of that. But in this second one, the value for the gradient will be given. So we are still using the same approach. M will be gradient, C is y-intercept. But in this second example, this is number 2. Let's take note of that. This is number 2. Then this one is number 1. Let's number our work. This is number 1. Okay. So let me bold it. Okay. Alright. So this is equation of a straight line. Equation of a straight line using gradient and a point. So how do we get this? Assuming a gradient is given and a point is given, how do you get equation of a straight line? Let me see demonstrate it here. So a point is given and gradient is given. So how do I get equation of the straight line? You know, this line already have a value for gradient. If you follow our last example, our last class, you will know how to get the gradient of a straight line with 2 points. 2 points is enough to get the gradient of a line. Just use your y2 minus y1. So let's leave that. So assuming gradient is given, gradient is m, then you have a point. How do you calculate the equation of the line? Which formula are you going to use? Let's derive the formula. So if I also use this point as that point that is given, x and y is the coordinate of the point, then the gradient is known. And what is the gradient? Let's come to our write-up. Remember, this is the formula for gradient. So let's move on with our solution. So gradient, we said if m is gradient, so m is equals to same y2 minus y1 divided by x2 minus x1. So this is gradient. Then the point given, then we say the point is, let's put it in statement. So the point given, the point is, let's take the point as x comma y. So this is the point. So the point is x, that is the coordinate of the point. Let's put, say the point is, for example, the point is A. Let's say point A, and it has coordinate x comma y. So this is the coordinate of this point. So a point is given and you know the gradient, and this is the formula we use in calculating gradient. So how do we get equation of the line? So what we need to do in this case is the first, that is the second coordinate. Remember I said I'm going to use this. The second coordinate is x comma y. So this is the second coordinate. So the first point will now be this point given. Will now be a particular, will be the point you are going to use, which is the y1 and y2. Let me put it in statement so that you understand what I'm saying. The point is, let me put it in, sorry, the point is A. Let's use mathematical mode, which is x2 and same mathematical mode, x2 and y. Okay, sorry, this should be x1, sorry, x1 and y. So this is the point. Let's put it in brackets. Okay, so this is the point. So the point is A, that is x1 and y1. So this is the point, but we don't know, but we need an equation. So since we need an equation, how do you get this equation of this line? You say m is equal to, so this time around you leave the y2 as this value. So this is the y2. So this is the second point. So y2 minus x1, we need another point. This is what I mean. So let's say there's a point. Let's say there's a point somewhere here. Let me put the point here. So this point, I'm calling it, let's say look for okay, which is x1. Okay, then which is y1. Okay, so this is what I'm talking about. Let me demonstrate it well so that you get what we are saying. So the gradient is already known and a point is known. So the point is x1, y1. That is what I'm trying to illustrate in this place. So this is the point x1, y1. The coordinate of that point A is x1, y1. But this other point, which is x, y, so this is the point we are going to use to do our calculation. So if I take my y2 now, which is y, no, I need an equation, so I'm not going to use a value. So y2 minus y1. So my y2 is y, so y minus y1, that will now be the form what I'm going to use here, not y2. So take note, it will now be y minus y1, then you divide it by, then x would be this other point. So x is this is the x2 now. So use x as x2, then x1 remains the same. So take note of that. Then you have your x minus x1. So this is the equation we are going to use. Then remember, we need an equation. We are not solving any problem now. We just want to derive an equation. Then what is now the equation of the line when a gradient is given and a point is given? The point is x1, y1. This is the coordinate of the point. So if I cross multiply with this, when I cross multiply, I'm going to have y minus y1 is going to be y minus y1 is going to be equals to m. Then you open bracket, x minus x1. So this is the formula you are going to use when they tell you to calculate the equation of a straight line using gradient and a point. So m is the gradient, then the point is x1 and y1. So they will give you a point, they will give you the gradient, they will tell you to calculate the equation of the straight line. So you use this equation fast, you get your result for equation of the straight line. So that's one thing I want you to know in this place. Just like the first one we did, how do you get equation of a straight line when gradient is given and y-intercept is given? So you use this formula. Gradient is m, the intercept is c, that is the y-intercept is c. Then the second equation of a line is saying that when they tell you to calculate equation of a line when gradient is given and a point, the point is x1, y1. Then the coordinate of that point x1, y1, then the gradient is m. So you use the second formula, and that is what we are talking about. Then the third one, which is our last objective for today, and that's where we are going to stop. Say, how do you determine equation of a straight line using 2 points? Assuming 2 points are given, no gradient is given, no y-intercept is given, but they just say find equation of a straight line and 2 points are given. How do you do that? So you can still use a formula, and that's the third one for today. So let's get that one. Let me just copy this fast. Okay, so the third one is equation of a straight line using 2 points. So equation of a straight line using or giving 2 points. Let's use giving 2 points. So when 2 points are given, so how do you get equation of a straight line? You still use the same formula. So we also start with m, which is the gradient, is y2 minus y1, you divide by x2 minus x1. So this is the same formula we are using, but 2 points are given. Okay, let's go to our sketch. Okay, let's take these 2 points. For example, this is a point, this point is given, this is the first point that is given, x1, y1. Then you have another point. Let's take this as another point too, x and y. Then let's create another point. Let's create another point. Let's say there's a point somewhere here. Still on this line, the point must not leave the line. Still on this line. Let's call it x2. Let me get the latex formula. Okay. So this is x2. Let's open bracket. Get our y2. Y2. Okay. So that is it. So x2, y2. You can see it. So x2, y2, x1, y1. So let's say these are the 2 points given. Now, so if these 2 points are given, the gradient will be y2 minus y1 divided by x2 minus x1. That's what we are saying. But we need an equation in this formula. So how are we going to get the equation? So this is what we are going to do. We'll use this point and this point. We'll get the gradient of this point and this point. We'll now make it equal to the gradient of this point and this point. That is this point and this point. So just take note, this point and this point will give us a gradient to be equal to the gradient of this point and this point. Since all 3 points are standing on this straight line, that we need the equation of the line. So which formula are you going to use? You will understand it when I put it down. So the first equation of formula the first formula for gradient we know is this, and I got it from this place, x2 minus x2 x1 y2, then y2 minus y1 divided by x2 minus x1. Then I'll now use this other equation, and gradient is also y minus y1 divided by x minus x1. So I'll equate both of them and move further a little. So that is all we are talking about. So the last equation will now be gradient, which is m, is also equals to y minus y1 divided by x minus x1. So this is what I'm talking about. Since gradient is equals to y2 minus y1 divided by x2 minus x1, gradient also is equals to y minus y1 divided by x minus x1. Therefore, both of them are equal. So that will give us the final gradient that we are talking about, the final equation of the line that we need. So when I equate both of them, so when you equate both of them, when you equate both equations, you are going to get, when you equate both of them, you are going to get y minus y1 divided by x minus x1, then equal to y2 minus y1 divided by x2 minus x1. So this is what we are talking about. So when 2 points are given, you can use this to get the equation of the line. The next thing is you solve down and represent it in the form that the question wants you to do it. So when 2 points are given, this is the formula you use to calculate the equation of the line. Then when gradient and a point is given, you use this number 2 formula. You get this. Then when gradient and y-intercept is given, you use this number 1 formula. So these are the 3 formulas you can use to calculate the equation of a straight line. Take note of these 3 equations. Gradient and intercept form is this. Gradient and a point is number 2. The number 3 giving 2 points. So that is all. You can actually turn this equation to look like this. All you just need to do is, gradient is m, which is this. You can see it, m. You can see. And when you calculate for m, then you cross multiply. You have your m open bracket s minus x1. And so number 2 and number 3, they're actually similar formula. So that is one thing you should take note of. So that is all for today's class. I will just give you few work to practice, just to substitute them into this formula and practice. In our next class, I will go further to give some examples on how to apply this formula to solve questions, and I will explain some concept you also need to understand in equation of a straight line. There are also many things you need to learn, but for now I think we are okay. For now, take note of these 3 equations. They are going to help us to calculate equation of a straight line when the need arises. So just go to this assignment, just a few questions just to practice those formulas we have. I said determine the equation of the following lines. I have a gradient of 3 and intercept of -2. Just substitute, use the first equation. Gradient is 3, intercept is -2. Then the second one says gradient is 4, passing through a point. This is gradient and this is a point. Substitute into the equation and you solve it. Then this one is equation of a straight line passing through 2 points. So you can use that, the last formula, which is number 3, to do it. So I just want you to go practice this first, but in our next class I'll do example on this kind of questions. But I just want you to try it first before we meet again. So thank you for listening. Hope you enjoyed today's class. Have a nice day. Bye.